Hey guys, welcome. Today let's talk about another type of trigonometry functions which is called as factorization and defactorization. Another simple but important concept and easy to score. Let's talk about it. So factorization, right? If you take the literal definition of factorization in mathematics, basically it's taking any kind of relatively not so easy or relatively complicated number or expression on one side and breaking it down to simpler concepts or simpler smaller units which can be used easily for computation or calculation. For example, if you see here, if I take a number 9, although number 9 is a single digit and it is easy by itself, but it can be broken down into two simpler terms called as 3 into 3. 3 multiplied by 3 is 9. So 3 is a small unit and the calculation works. If the number 9 was bigger number, you could have easily broken down into still a smaller number and you could have factorized that and used it for further calculation. If you take 9 plus 6, which is a sum of two numbers, which is 15, so I can factorize that into as 3 into 5. Similarly, instead of numbers, if you try to take an algebraic expression, say a square minus b square, and if I try to factorize or make it more simpler, I can say that a square minus b square is equal to a plus b into a minus b. So that's the concept of factorization. So just taking something which is relatively looks seemingly complicated and breaking it down to simpler terms, that's factorization. In trigonometry also, it kind of has the same relevance. And the only thing is in trigonometry, what you do is when you say factorization, basically the formulas are pretty much defined and what is the implication of that is pretty much there so that you don't have to worry about how to factorize. For example, in terms of factorization, what basically it means is take the expression any two trigonometry functions, pretty much sine and cos, and whatever is the sum and difference on the left hand side, you factorize into a product formula so that you can compute values easily. That's called as factorization. So taking a sum and difference formula of sine and cosine and then breaking it down into a product rule or product of two functions is called as factorization. And defactorization is pretty much the opposite of that. You take two functions that come in together in the context of sine and cosine. You take them together and you just convert them into a formula on the right hand side, which looks like an algebraic sum or difference, like I'm showing it here. So that's called as defactorization. So factorization is taking sum and difference and converting that into product of two functions. And defactorization is taking product of two functions and converting that into sum or difference of two functions. And within the context of the syllabus and the formulas, we'll confine ourselves to sine and cosine. I don't even think that factorization, defactorization exists for tan and other functions. Or we have already seen tan A plus tan B in the earlier syllabus. Yeah, it does exist. Okay, so let's focus on this one. So that's the definition of factorization and defactorization, and it's kind of interesting that it's easier to understand the defactorization first and then the factorization because of the way the formulas are structured. Because if you come here, you will see sine c plus sine d and you will see all the c plus d by 2 and you might say, wow, where is it coming from? But if you see on the left hand side, the defactorization side, it pretty much looks simple to understand. So let's understand this first, the left hand side, defactorization, and based on that we can understand the factorization. And the good news is you don't have to memorize all the formulas. If you just memorize one, pretty much you can get all the other formulas. And the other good news is proving these formulas, although it's easy, I'll put out another optional video that you can watch if you're interested. But proving these formulas and how did it come from is out of syllabus, so you don't have to worry about. You have to just memorize this formula in whatever way you can, whatever best suits for you, and you have to just solve the problems using this formula. So the theory part of that, or the theorems of proving this, is out of syllabus, whereas application of this formula is pretty much in the syllabus. So let's get down to business, guys. So if you see here, I'm just going to tell how I see it, and then you can memorize it the way you want. And I'm going to put another optional video which will be more easier to understand where it came from, and you can memorize it easily. So if you remember, everything, all of this come from the sum and difference formula. That's kind of the mother formula for all of that. If you remember, sum and difference is sine a plus b, just this piece of that. If you remember, sine x plus y is sine x cos y plus cos x sine y. We have done that in the type 1 problem. So everything is kind of based on that one. So there are 4 formulas on defactorization, and there are 4 formulas on factorizations. And if you see that, if you see on the left and right side, there is a relationship, and they are derived from each other. It's very clear. So on the left side, I'm not going to focus more on how to memorize that formula. I'll just leave it to you however you want to memorize. It's not difficult. The way I memorize it, anything that is a sine function, sine and cos, if you have 2 functions, sine and cos, which is product, then the overall on the right hand side, it's all about sine only. Whereas if it's all of cos and all of sine, then on the right hand side, it's all cos functions. So if you get this, then you can get this easily. So don't worry about how you memorize, just memorize it however you want. It's not that difficult, and there is a relationship. Like if you see here, 2 sine x cos y is equal to x sine of x plus y plus sine of x minus y. So if you take the right hand side over here, and if you see the left hand side over here, it matches, right? The sine x plus y is similar to sine c, where c is x plus y. Similarly, d is x minus y. And then you can, if you see the right hand side over here and the left hand side of here, you can draw similarities. So you can use that to memorize the formula. And if you're struggling with this, just don't worry about that. Just go with the flow for now and check out my other optional video to understand where it came from, and then you'll appreciate that it's not that difficult to remember. So assuming that you remember this formula, the only catch is the last 2 formulas on both the sides, right? So there is a negative sign here. That's an exception, and I'll tell you why it is in the next video. But for now, you just understand this. There's a negative sign here. And over here, either you can add a negative sign here, or instead of using the c minus d, the negative sign can be removed, and instead of saying c minus d, you can do d minus c. So those are the 2 exceptions that where you have to remember. One is this, and one is this portion, okay? And we'll talk about that in the next video on why it is, but for now, go with the flow. So assume that you have kind of memorized all this formula. There are total 8 formulas, and if you know one, you can derive the rest of them. So the 4 of them are on defactorization, and the 4 of them are on factorization. So let's first understand with a couple of examples, where is this relevant? Why should I use that? Okay, so let's take the defactorization first, for example. Okay, so if you see, let's say you have equations like this: 2 into cos of 75 into cos of 15, and like, how do you solve that? So one way of solving that is, if you remember, we have already seen the type 1 where you can express 75, okay, as 40 plus 35. Okay, you can express it that way, or maybe hold on, the other way, because the values will not be there. Just one second, let me just erase this. Sorry about that. So let's say you can express 75. If you remember, we have solved this problem on sine 75. You can express this saying that it's 45 plus 30, because both are standard angles, and you know the values of that. So you can say cos 75 is cos of 45 plus 30, and cos of 15 is the difference of that 45 minus 30. And then you can apply the individual formula of cos of a plus b and cos of a minus b and solve that. That's one way of solving that, and that's why we started the trigonometry. But as we advanced and matured, there could be possibly easier ways to solve that, which is nothing but just apply one of these formulas and say whether we get the value or not. And let's try to do that. Okay, so if you see here, we have got 2, and it's a product of 2 cos functions. Okay, so angle 1 is 75, other angle is 15, and let's try to see where it fits in. So where are the 2 cos functions? So if you see, the 2 cos functions are here. Okay, so if you apply this formula, this left hand side over here matches with this over here. If you see, 2 cos xy is 2 cos 75 and 15, which pretty much, what does it tell you? What it tells you, that x is equal to 75 and y is equal to 15. So let's try to see if we can apply this formula over here. Okay, let's try to see if we can get this formula and see what is the answer, instead of going the type 1 route, which I taught you, which is another way of doing that. Let's see whether this kind of simplifies our job. So if I just apply this values into this formula on the right hand side, what you get is right hand side is equal to cos of x plus y. X is 75 and y is 15, so that gives you 90, and plus it says cos of, if you say it's here x minus y, that is 75 minus 15, that's going to be, I think, 60, right? Cos 60. So if you, and then once you simplify this, you know that both of these are standard angles. So what's going to happen is cos of 90 is 0, you know that, and cos of 60 is 1 by 2. So the answer is 1 by 2, half. So this equation, which looked very goofy or weird to start with, 2 cos of 75 and cos of 15, how am I going to calculate? You have easily simplified using this formula, and you got the answer as half. You could have done this way, just apply formula and get the answer, or you could apply the traditional way and just did some substitution, you could have still got. But this is a much faster way to do that, and that's how you appreciate that where does the defactorization come in as an example. So that's one way of looking at that. That's an example. Now let's go on the factorization part. Let me take this blue color on the factorization. So let's say in factorization, it's basically there are two functions, either both are sine or both are cos. That's kind of common here also. See, both are sine or both are cos on the right hand side. Over here on the left hand side, the right hand side of this part will kind of match the right hand side of left hand side of this part, and you will see that either both the functions are in sine or both the functions are in cos. That's how you kind of memorize that. So if you see here, let's say I give you an equation, let's say what is the value of, or how can you simplify this equation? Sine of, there's an angle A plus pi by 6, which is 30 degrees, 180 by 6, minus sine of A minus pi by 6. Can you simplify or get a value of that? So just like how it looked kind of weird to start with, this also like kind of looks weird to start with, and if you try to calculate this, it's very complicated. But if you simplify it using one of these formulas, you will see that okay, it sounded complicated, but I can use this formula, do some magic and simplify the equation. And I'm going to just give you solve this real time for you. So if you see here, it's two sine functions and there is a negative sign, so it's a difference formula over here. And if you see, where does it match to? It matches over here, right? This is where it matches to. Okay, sine C minus D. So you can assume that this whole angle is A plus pi by 6 is C, and A minus pi by 6, the whole of this is D. So basically what it means is, let me take a different color here. Okay, so what does this mean is this whole part is C and this whole part is D. Okay, so with that, let's try to solve and see whether it makes our job easy. That's what we're trying to figure out. Okay, so if I just directly apply the formula, whatever is on the right hand side, so I can see, I can write it here. The right hand side of that will be 2 of cos. I need to add both the angles and divide it by 2. So I'm going to add this C, which is A plus pi by 6, plus D is A minus pi by 6, the whole divided by 2. Okay, that's how I'm going to add that. And then there's a negative sign here. So there is, and it's a product rule, right? So the negative sign becomes a product rule, 2 cos into sine. So I'm going to just write down sine here. Let me see if I have space here. Otherwise, I'm going to just write it down here. I'm going to just write it down. Okay. So, and I'm going to use a different color so that you don't get confused. Let's say, okay. So into sine of C minus D, that means A plus pi by 6 minus A into the, okay, this doesn't look like a, hold on, let me erase that. Okay, so minus in the bracket A minus pi by 6 divided by 2. That's how it looks like, right? This equation, if you simplify. So if I simplify further, let's take the blue part first. If I simplify further, it will become 2 of cos, and if you see this A plus A is 2A by, okay, hold on, I'm writing A as a pi, hold on. Okay, so 2A upon 2, and this pi by 6 minus pi by 6 gets cancelled, right? I can see it here. It can get cancelled. All right, so it get cancelled. So this blue equation is 2 cos 2a by 2 into, now let's worry about this function in the yellow color. So this becomes sine. Okay, now over here the a and this a will get cancelled over here. So let me use a different color. So this a and a will get cancelled, and this negative and this negative will become positive. So it will become pi by 6 plus pi by 6. So it will become 2 pi by 6, right? 2 pi by 6 divided by 2, because this 2 is still here. That's how the values are there, right? So if I simplify this again, what I get is twice this 2 and 2, this gets cancelled, this gets cancelled, right? So I get 2 of cos a into okay, so what do you get? So this 2 and this 2, sorry about that, this 2 and this 2 also will get cancelled. Just one second, let me get my pen right. Okay, so this 2 and this 2 get cancelled, and what remains is sine of pi by 6. Sine of pi by 6, we know that it's sine of 30, so it's going to be half. So if this equation will become 2 of cos a into half, and then this half and this half gets cancelled, and what remains is cos a. So the whole equation over here you simplified into a simple using factorization. You started from here, and the whole thing you simplified into cos a. So that's the beauty of the factorization that I was talking about. So that's kind of gives an example of why you can apply, where you can apply, and how that's relevant, and how that is make your job easy. Okay, now let's move on. Let's try to solve some of the, let's see what kind of problems you get in the exam. Okay, so for the first year diploma for the Maharashtra State Board, if you see all the last 3 or 4 years of papers for the new syllabus, you definitely get, for each paper you get 2 problems for 4 marks each, so that makes total 8 marks, and there are typically only 3 variations. It keeps on repeating. There are nothing much more than that. There are only 3 variations where they ask you to prove something, prove that left hand side is equal to right hand side. They give you both equations and you have to prove, and I have put all the variations. So there's one variation that is on the De-Factorization formula that you saw here. For example, over here, converting the product side into the sum and difference, and the 2 remaining variations are on the factorization part, where if you can see here, they might give you a equation that will look like a sum or difference, and then you have to convert into a product or some other function. Those are the 3 variations, the variations you get. So let's see what happens. So on variation 1, like I said, it's about de-factorization, and the problem will look like, you can see here, it will be a series of cos or sine functions multiplied. So it will look like a product equation, and then you have to substitute and get it. And on the other 2 variations, it will be on factorization, and one of the variation would be, there will be an equation on the left hand side, but on the right hand side there will be just one trigonometric function, nothing more. Just one function. You have to prove that left hand side is equal to right hand side. Even over here, if you see, it's a big, on the left side it looks like a big equation, but right side is just one trigonometric function. That's it. That's one variation. And the other variation, the last variation, is on the left side you get a big function, and the right side also, instead of just one trigonometric function, you can get a combination of trigonometric functions in the form of an equation, something like this, where you have cos, you have sine, you have tan, or it could be anything, but it's not just one function, right? Over here it's just tan a and 5a. So these are the 3 variations you will get: variation 1, variation 2, and variation 3 in exam, nothing more than that. So that's your cue to understand that, okay, this is like a factorization problem, and this is a variation 1 or a variation 2 or variation 3, and which one can I apply. So these tips and tricks kind of help you jumpstart in the exam if you're struggling to how to start. And how do you identify the pattern? How do you know that this is type 6 problem, and how do I start? So I put some simple tricks here to see whether you can mentally do some mental mathematics to see whether this is a type 6 problem or some other type. And this problems look very unique, and you can easily identify type 6. Some of the instances it might look like a multiple angle and you might get confused, but I'm going to put another video to see that it's not a multiple angle formula, it's type 6 factorization problems, but I'll put that in a separate video. But for now, just remember these 4 bullets on how to find your Q's. For example, the first one is angles individually cannot be solved very easily but when you do a sum and difference, then it becomes very easy. For example, if you take this, you can take cos 20 or cos 40 or cos 80, because cos 60 has the value, so you don't have to worry about that. But if you take any of this 20, 40 or 80 and you just try to compute their value individually, it's very difficult. Mentally you cannot do that because it doesn't look like a standard angle. But what you do is, if you take this 20 and if you take this 40 and if you try to do and sum or difference, for example 40 plus 20 is equal to 60. So now you know that the value of 60 is a standard angle and you can compute that. Or you can take any 2 angles. For example, let's say I take 80 and I take 20. So 80 minus 20 is again 60. So either the sum or the difference, one of them will give you a standard angle or some angle for which you will know the value and you can compute that. That's your clue number 1 over here. The second one is numerator and denominator on the left side will have the same number of terms in the form of trig functions. So if you come here, if you see here, the numerator and the denominator, over here you have sine 3a minus sine a. So the numerator has got two trigonometric functions, 2 terms which has trigonometric functions. At the bottom also you have cos and cos, they are true. So the numerator has 2 terms and the denominator has 2 terms. Over here also, if you see, the numerator has got 3 terms, the denominator has 3 terms. Same like here, it's 3 and 3. So in another cube is the numerator and denominator will have kind of the same kind of terms in terms of same number of terms in terms of trigonometric functions. So that's another clue that, hey, this could be a factorization formula, because it kind of makes perfect sense where you can apply the formula directly. So that's your second point. The third point is angles could be weird. It could be odd, it could be even, it could be mixed here. If you see here, it's all weird angles, 20, 40, 60, 80, sine of 3a, sine of a, again sine of 4a, sine of 5a, sine of 6a. It just goes on. It's just all over the place. Typically, in the other types that we saw, it was kind of having a pattern and it was very finite, but over here it can go in anyhow and you will not know. Typically, the odd functions, when you have a sine 5a, it's very difficult to put this into a multiple angle formula because it's an odd function and you cannot do that. That's another clue that you might check in the problem. The other thing is angles. The angle part on the right hand side function might match to the angle part on the left hand side function. And what do you mean by that? If you see here, the angle part over here is a on the right side, and on the left side also you might have some function with an angle exactly what is there on the right side. So over here the right hand side has the angle a, and the left hand side over here also has a. Over here the right hand side has an angle of 5a, and you can see the left hand side also has angle of 5a. So you can see there's a pattern here. Over here you can see that right hand side is the equation and it has got angle a, it has got angle 3a. So it has got both the flavors. But if you see on the left hand side, you will still see the flavors. For example, over here you see there is a, and over here you will see there is 3a. So that's another way to look at that. Okay, hey, that matches. There is something interesting. Another clue. And last but not the least, but the most important, when you add up any 2 angles, they're always even, so that the formula can be applied, especially factorization. What does that mean? So if you see the factorization formula over here, right, you take the equation on the left side and you apply the formula on the right side. So it will be always c plus d. You will be adding up those 2 angles or subtracting them and dividing it by 2. Okay. So once you do this maths, addition and or subtraction divided by 2, it cannot be odd angle. If it's an odd angle, it will be very hard for you to calculate. So all the problems that you'll get in exam, right, it will be always even. For example, if you take here, let's take any 2 angles. Let's take over here 2a plus 4a. Let's say if you sum it up. So if you sum it up, so let me write it down here. Hold on. Okay, okay. So if you sum this one over here, so if you sum it up, 2a plus 4a is going to be 6a, and then I need to divide by 2, and it's easily divisible, so it gives me 3a. So let's say if it was not 6a over here, right, it was 5a, then it will give me in decimal, it will be 2.5. I don't want to do that. And if I take the difference of this, which is 4a minus 2a is equal to 2a, and again I divide by 2, again the 2 goes off because it just gives me standard angle. So like that, you can see that you can pick up any two angles, 3a over a. If you add or if you subtract and then you divide it by 2, it will be easily divisible by 2, so that you don't get an odd angle or you don't get a decimal. So that's your clue. So whenever you get those patterns, any of these patterns, all of these patterns, you should know that this is a type 6 problem, and that's how you should apply the formula. So that's all I wanted to do in terms of explaining the concept, introducing you to the concept, and then the next video we'll talk about how to solve this. These are actual examination problems. We'll solve about that. I'll solve it real time, one at a time, and then you can see that. And I'm going to put another optional video. This you guys don't have to view it if you're not interested, and no one is going to ask you in the exam. But if you're not sure how this came from, I'm going to explain you two things. I'm going to explain where did this formula come from, what the factorization, De-Factorization, so that it will be easier for you to memorize. There are different ways to memorize that, and I'll teach you a few tricks. If you understand where it came from, it's easy to memorize. That's number one. And number two is, I already explained you when to apply it, but sometimes there are a couple of instances where it might look like, hey, it's a multiple angle formula, and that's when you apply all of these tricks to make sure that, hey, this is not really multiple angle. I can solve it using factorization. It's not that you cannot solve using multiple angles, but like I told you, sometimes using this formula can give you the results very easily in simple few steps, as opposed to solving it in a more elaborate or complicated steps, or taking more time consuming steps. So those are the tricks. So I'm going to put an optional video. Just if you're curious, you can watch it. If you're not curious, you got this is good to go. You can go straight away skip the optional video and get into the video where I'm solving these problems real time. Okay, so more on the other side. Thank you.